Good morning, everyone. Um, Welcome to the class. First of all, let me discuss about your midterm exam 2 performance. The performance is really good. The class average is also really healthy. So keep up the momentum. Um, and again, if you need my help to understand any concept or anything, you have the office hour posted in your syllabus and you have the Zoom link to actually jump into the office hour. So I'm always available. At the same time, if you need time outside the office hours, I am happy to make a schedule for you. In that case, please email me and then we are going to make a schedule at our convenience. All right, now let us start the problem solving part of chapter number 9. And remember, chapter number 9 is about bond valuation. We already covered the theoretical part. The very first question is about valuing bonds. So let us check the information, what is provided. So here you can see we have a bond which will mature 10 years from now. And then the face value of the bond is $1,000. But again, for your information, even if you don't have this information and nothing otherwise stated, say par value is equal to $2,000 or $5,000, you don't have that type of information here. So the face value of the bond is omitted from this particular question. In that case, according to the bond market convention, you must have to assume that the face value of the bond is how much? $1,000. Then coupon interest rate is 9%. And then the market required rate of return is 15%. Now the question is, what would be the value of the bond if the bond pays interest semi-annually? Before we start, let us also discuss the other bond market conventions. So here, even if we don't have the information about how frequently we get the interest, we still need to assume that the interest is paid semi-annually. So that is a bond market convention. So in the question, if it is not specifically mentioned that your interest rate, your interest payment are made at some other frequency, say monthly, yearly, daily, quarterly, then you always have to assume that the interest is actually paid semi-annually. All right. Now, let us use the formula to calculate the value of the bond, provided all of the information. So this is the formula we are going to use to calculate value of the bond. So we got our formula. So here you can see we need to know our semi-annual coupon. We also need to know our periodic interest rate or periodic market rate or periodic required rate of return. Then we need to know our total number of time periods. Then we need to know the face value of the bond, which we are going to get at maturity. So let us calculate each of these pieces of information. The coupon is equal to so we always apply our coupon rate over the face value of the bond to calculate the coupon. Remember, never ever apply your coupon rate over the market value of the bond or the price you pay to purchase the bond to calculate coupon. You always apply your coupon rate over the face value of the bond to calculate coupon. So here, your face value of the bond is $1,000. Your coupon rate is 9%. However, this 9% is your annual coupon rate. Now we need to calculate our periodic coupon rate. So to calculate our periodic coupon rate, we need to know how many times we get payments in a year. So you can see here, we get our interest semi-annually. That means we are paid twice a year. So that means we have 2 time periods, right? So we are going to divide our annual interest rate by the total number of periods per year, which is 2, to get our periodic coupon rate. So our periodic coupon rate in this case is 4.5%. So if you calculate, you're going to get coupon is equal to $45. Then let us calculate our required rate of return. Of return is equal to, so you can see here, the yield to maturity is how much? 15%. So yield to maturity is our market interest rate. In this case, we have 15%. However, this 15% is the annual rate. So in order to calculate our periodic yield to maturity or market interest rate, we need to know the frequency at which we are paid in a year. So as I discussed earlier, we are paid twice a year. So we have 2 periods per year. So divide our market interest rate by 2 or yield to maturity by 2 to get our periodic interest rate. So in this case, our required rate of return is 7.5% per period. Now, let us calculate our total number of periods during our investment horizon. So total number of periods is equal to, so we have in total 10 years, here you can see. However, in each year, we have how many periods? We have 2 periods. So the total number of periods in this case is 10 times 2 is equal to 20. Then FD is equal to face value, and face value in this case is $1,000. So now we got everything we need to calculate our bond value. So here you can see our coupon is equal to how much? $45. Our required rate of return is how much? 7.5%. Then our Total number of time period is equal to how much? 20. Again, let us put value for R is 7.5%. Again, it is 7.5%. And then T is equal to 20. Face value is equal to $1,000. So you can see here. Here the key is to actually estimate the value of each of these factors. Once you calculate the value of each of these factors, the subsequent steps are really, really easy. You just plug in numbers into the formula and get your value. So let us calculate. So we are now calculating the value of this part, the numerator part here. So first of all, 1 plus 7.5% to the power 20, then 1 divided by whatever is your answer, then 1 minus the value of this part. So 1 minus second this. So this is the value of the numerator part here. Then divided by 0.075. Then the value of this entire part is how much? 10.1945. Then multiplied by the coupon, $45. So the value we get here for the coupon is 458.7521 plus. Now we are going to discount the face value of the bond. First of all, 1 plus 0.075 to the power 20. Now 1000 divided by whatever the value of our denominator here. So it is $235. Now our total value of the bond is $694.1652. So this is the value of the bond. Now, from this particular exercise, we learn how to apply formula in calculating the value of the bond. Now we are going to apply financial calculator to calculate the value. Okay, so from here on, I'm going to use financial calculator to solve all the subsequent problems, because here we just in the bond valuation chapter, we just have one formula. And in the very first problem, I showed you how to use the formula to calculate the value of the bond. So to solve other problems using the same formula, you're going to repeat the exact same process to calculate first the value of each of the factors. Then you're going to just plug in the value of the factors in the formula in calculating the bond value. Okay, so now let us use financial calculator. So to calculate the value of the bond, we are gonna use these options in your financial calculator. And the reason we use the annuity options in your financial calculator, because bond is also a type of annuity. So whenever you invest in a bond, you get fixed interest payment for a particular time period. So for a finite time period. And then these interests repeat at equal time intervals. So in the financial calculator, we need the value of the factors N, IY, then PV, then PMT, then a B. N means number of time periods, number of time periods. IY means periodic required rate of return. PV means current market price. PMT means periodic interest. AB means face value. Right. So now we already calculated each of them above. So you can see here total number of time period we calculated earlier is 20. Periodic required rate of return we calculated earlier is 7.5%. Then current market price we calculated is how much? So not we did not calculate. So we are going to calculate that. So we don't know this factor. So put question mark here. So this is what we want to calculate. Then periodic interest is equal to $45, as you can see. Face value is equal to $1,000. Now, whenever you put value in the financial calculator, you need to know what is your inflow, what is your outflow. Now, in the bond valuation part, you can take the perspective of either an investor or a firm. So let us do it from the perspective of a firm. Whenever a firm issues new bond to the market, what they get is the market price. So market price here is the cash inflow for the firms. Now, in return, firms need to pay periodic coupon in the future, and then they also need to pay the principal value of the bond at maturity. So both interest payment and face value of the bond, which is the principal payment at maturity, are outflows for the firm. So therefore, the sign of the outflows, because the sign of the outflows is negative, so we are going to put negative sign in front of both periodic interest and face value. All right. Now let us use financial calculator to find the value of the bond. So first step we have in the financial calculator is clear the memory. So type 0 and then plug in this value everywhere. So now we clear the memory. Let us now plug in numbers. So N is equal to 20. IY is equal to 7.5. Don't put 7.5%. It is 7.5. Then periodic interest, negative $45. FD, negative $1,000. Now let us calculate price. So compute, then price. So the price we get here is how much? $694. 16 cents. So that is exactly what we get here. The PV here is equal to $694.1653. All right, now in this problem, we are going to again compute the value of the bond, and then it says enterprise incorporation bonds have a 9% annual coupon rate. Now this is the annual coupon rate. The interest is paid semi-annually. So 9% coupon rate, interest is paid semi-annually. And then the bond matures in 8 years. So we have 8 years time period left. The par value or the face value of the bond is $1,000. Market rate of return or market required rate of return or yield to maturity is how much? 8%. Then what is the value of the bond? Then we have second question where it says what is the value of the bond if interest is paid annually. So let us solve them in sequence. First, we are going to start with the scenario where interest is paid semi-annually. Right. So let us now first find the value of each of these factors. Now here, the total number of time periods we have is 8 years, 8 times. Here interest is paid semi-annually. So the unit of time period here is semi-annual. And then how many semi-annual periods do we have in a year? We have 2 semi-annual periods a year. So 8 times 2 is equal to 16. Now, yield to maturity or market interest rate at each period. So first, our annual yield to maturity is 8%. And then we are going to divide it by the number of periods per year to get our periodic rate of return. So we have 2 periods per year because the payments are semi-annual. So 8% divided by 2 is equal to 4%. This is our periodic required rate of return. We don't know the market price. Now let us compute periodic interest. To compute periodic interest, we apply the coupon rate over the face value of the bond. So face value of the bond is $1,000. And then we are going to apply our periodic coupon rate over the face value of the bond to calculate our periodic interest. So our annual coupon rate is 9%. And as usual, our total number of periods per year is 2. Accordingly, we get the periodic interest equal to 45, but remember the sign should be negative. Why? Because periodic interest is an outflow for the firm. Then face value, as mentioned here, is $1,000. And again, the value should be negative. Why? Because firms need to pay this amount at maturity. So this is a cash outflow for the firm. Now, let us plug in all of these numbers into the financial calculator to compute our value. So we are going to do it in 2 steps. In step number 1, we are going to clear the memory. In step number 2, we are going to plug in numbers and compute. So first type 0 and plug in zeros everywhere. Now our calculator is ready to compute our next value. So let us now plug in numbers. So n is equal to 16, then IY is equal to 4, then PMT is equal to negative 45, face value is equal to 1000. So now let us compute our present value or current market value. So compute PV, which is $1,058.26. So here, if interest rate or coupon is paid semi-annually, then the value of the bond is $1,058. Now we are going to do it if interest is paid annually. So whenever interest is paid annually, then number of periods we have per year is 1. The total number of periods per year is 1. Why? Because the frequency of payment is now annual. So our total number of time period is 8. Then our IY is again 8%. Why? Because our total number of time period per year is 1. And then our periodic coupon rate should be equal to $90. So these are the only changes. So let us now plug in these numbers into the financial calculator to find the new value. Again, we are going to clear the memory, then we are going to plug in now. Let us type 0 everywhere. Now n is equal to 8, IY is equal to 8. We don't know PV. We know PMT is equal to negative 19. Face value is equal to negative 1000. Now compute present value. In this case, the value is 1057.4664. All right. Now, in the next one, we are going to value the bond, but in this case, we don't know directly what is the yield to maturity of this bond, but we have the credit rating of the bond, and then we also know the yield to maturity of the bonds with similar credit rating. So as we discussed in our theoretical part, in this case, we can use the yield to maturity of the bonds with similar credit rating from the market as the yield to maturity of our own bond. So here you can see this particular company will issue a new bond which will mature 20 years from now. Annual coupon rate is 8%. And then par value of the bond is $1,000. Interest will be paid semi-annually. And then they are hoping to get AA rating. And the yield to maturity of the AA rating is 7.5%. However, they are also very conservative. They also collected the yield to maturity of the bond with A rating. So here, the yield to maturity of the bond with A rating is 8.5%. Now, their question is, what will be the price of these bonds if they receive either an A rating or an AA rating? So let us do it for AA rating first. Now, you can see here, the bond will mature 20 years from now. So we have 20 years, and then this bond will pay semi-annually. So now we have total number of periods per year equal to 2. So then total number of periods in the entire investment period is 40. Then our yield to maturity for a AA rated bond is 7.5%. And we have 2 periods per year. Then our yield to maturity per period is 3.75%. Next, our coupon rate. Our annual coupon rate is 8%. Then our periodic interest is $40, and the face value of the bond is $1,000. So now let us calculate price. First, we are going to clear the memory. Now let us plug in numbers. So n is equal to 40, IY is equal to 3.75, and then PMT is equal to negative 40, face value is equal to negative $1,000. So now compute present value. So the value of the bond is $1,051.3775. Any question here so far? Okay. Now let us move to A rating. So in A rating, we have all the information to be the same, but the only change is the yield to maturity. Now, yield to maturity or market interest rate per year is 8.5%. So our annual yield to maturity is, sorry, our periodic yield to maturity or market rate of return or required rate of return is 4.25%. So now let us plug in numbers. So first we are going to clear the memory. Then we are going to plug in numbers. Next, compute present value. So the present value here is $952.3068. So now we can see here from the first case to the second case, our required rate of return actually increased. In the very first case, our required rate of return was 7.5%. In the second case, it is 8.5%. Now, as you can see, as the required rate of return increases, price of the bond declines. In the next problem, we are going to calculate yield to maturity. All right. So now here we have a 20-year bond which pays 9% interest annually on top of the $1,000 par value. This bond sells for $945. So now we have the price of the bond. Then what is the bond's yield to maturity? Next question is, what would be the yield to maturity of the bond if the bond paid interest semi-annually? So here you can see in the very first case, it says the bond pays interest annually. And then in the second case, it says the bond pays interest semi-annually. So let us separate them. First, we are gonna compute yield to maturity for semi-annual, for annual coupon or interest payment. Now it is a 20-year bond, and then remember here we pay our interest annually. So our unit of time period is annual. Then we have one time period per year. So total number of time period we have is 20. And then our yield to maturity, we don't know. This is the question. Next, our current market price is $945. It should be positive because firms get this money whenever they sell bond to the market. Now our periodic coupon rate is 9% divided by 1. Remember why? Because here our annual coupon rate is 9% and we pay our coupon annually. So our unit of time here is annual. So our annual coupon is $90. Our face value is $1,000. Now let us calculate IUI. So first, we are going to clear the memory. Then let us plug in numbers. So N is equal to 20. Then current market price is $945. PMT is negative 90. Face value is negative $1,000. So now compute IUI. So our yield to maturity here is 9.6298%. Now, because here you use annual coupon and annual, number. So here you use annual coupon to compute this yield to maturity. So the yield to maturity or market interest rate you compute is also annual. Now let us repeat this problem for the semi-annual time period. Whenever interest is paid semi-annually, then our unit of time here is semi-annual, and we have 2 semi-annual time periods per year. The total number of time periods should be 20 years time, 2 semi-annual periods per year equal to 40. Then our periodic interest rate should be 1000 times annual coupon rate divided by 2, because 2 is our number of time periods per year. So let us now calculate yield to maturity. Again, we are going to clear the memory. Then let us plug in numbers. N is equal to 40. Current market price is 945. PMT is negative 45. Face value is negative 1000. Then compute IY. So IY here is now 4.8123. Now, because here you used semi-annual coupon to compute this IY or yield to maturity, this yield to maturity is semi-annual. Now we need to convert it into annual IY. So annual IY is equal to whatever you calculate here, you need to multiply it by number of time periods. So number of time periods we have per year. Sorry, you need to multiply number of time periods per year. So number of time periods per year is 2. So our annual yield to maturity is 9.6247%. Now you can see here, whenever your coupon payment was annual, your yield to maturity was 9.62%. Whenever your coupon payment is semi-annual, your yield to maturity is 9.6247. So actually, annual, whenever you use annual coupon rate, yield to maturity is greater than the yield to maturity whenever you use semi-annual coupon rate. So whenever you have semi-annual coupon rate, then basically you compound your interest more frequently, and therefore you need lower yield to maturity than the yield to maturity in annual coupon payment in order to get the same market price. All right. Now, next question. What would you expect the nominal interest rate to be if the real interest rate is 4.5% and inflation is 7.3%? All right, let us copy the formula. So here we want to know the nominal interest rate. Then let us just plug in numbers. So let me keep this formula and then put another one. So real interest rate here is 4.5%, and then inflation rate is 7.3%. You can see we just plugged in numbers in the Fisher model we discussed in the theoretical part. Then our nominal interest rate here should be, let us take this one from the left side to the right side of the equation. So whatever value you get, then minus 1, right? So let us now calculate. So it is 1 plus 0.045, whatever you get, then times 1 plus 0.073 minus 1. So our nominal interest rate is 12.13%. Now we have similar problem here. So it says our expected inflation is 3.8%. Our real interest rate is 6.4%. Then what would be our nominal interest rate? So again, our real interest rate here is 6.4%, as you can see here. And then our inflation rate is 3.8%. Again, we are going to take 1 from the right side of the equation is to the left side, sorry, from the left side of the equation to the right side of the equation. Now let us compute. So 1.064 times 1.038 minus 1. So the value is 10.44%. Again, you can see here, we just have 3 factors in this Fisher effect formula. So if you know 2 factors, you can actually calculate the value of the other factor. So in the exam, I may give you the value of the nominal interest rate and inflation rate, then you should be able to calculate the real interest rate. Or I may give you the value of the nominal interest rate and real interest rate, then you will be expected to compute inflation rate. All right, that's all from the chapter. Do you have any questions so far?
No, thank you.
You're welcome, Joyce. You have a nice day.
You too. Thank you.
Bye.